This hack tip is brought to you by Hak5 and viewers like you. Support us directly at hakshop.com. Welcome to HakTip, the show where we break down concepts, tools, and techniques for hackers, gurus, and IT ninjas. I'm Shannon Morse, and today we are checking out Wireshark and name resolutions. So let's talk about these name resolutions. This is basically used in several different programs to convert one address into another, such as changing a computer's MAC address into something that makes sense, such as a DNS or an ARP, spelled ARP. So this could be a .com name, for example. That would be something understandable, correct? Now you can enable these under Capture under Options. So if I go under Capture and I go to Options, I'll have the option under here to actually change those MAC addresses. Now resolving MAC addresses means that Wireshark will try to resolve the layer 2 or layer 3 MAC address. Resolving the network layer names, the second option that you have, means that Wireshark will try to convert something like an IP address into an easier to interpret DNS name. And then last you have resolve transport layer names. This means that Wireshark will try to convert a port number like port 80 into whatever that port stands for, such as HTTP. Now keep in mind that name resolution doesn't always work. Your network needs to be set up correctly to interpret DNS names, and these servers have to be online to work every single time that you run a capture. It also requires a little bit more power under the hood as well. Now here's something kind of cool that I just found lately. If you go under statistics, so I'm going to close this out and go under statistics, and then there's this thing called packet lengths. Click on packet lengths and you'll see a filter option. So I'm going to choose a filter. Let's choose TCP only. And then I'm going to go to create stat, and I'll get this nice little graph. So you'll notice under here that most of the packets are between 1280 and 2559 bytes. So if I go under here, under 1280 to 2559 in packet lengths, you'll find that most of my packets, 5,794 of them, are actually between those counts for that packet size, for the bytes. Now this usually ends up being some sort of data, whatever kind of data is being transferred back and forth. The second largest packet length that you'll usually find is between 40 and 79, and this pretty much happens with almost every single capture that you do. Now again, this is in bytes, so that would be 4,558 different packets that are between the byte sizes of 40 and 79. These are most likely just protocol control commands, so anything that establishes some kind of connection or some kind of protocol. Now I thought it kind of interesting that most of them are between 40 and 79 and that 1280 and 2559. No matter what kind of capture you do, it just depends on, well, your count obviously will change depending on how long you've let that capture go, but for the most part you'll find that all of your packet lengths are between those two different criteria. It's kind of interesting that all the packets just end up being those same exact sizes. Huh, how strange. Now, right after the break, I'll have some more interesting facts for you, including some feedback. We'll be right back. The Hack Shop is Hak5's premier store for all of your pen testing needs, including one of my favorites, the USB Rubber Ducky, which looks like a flash drive and it types like a keyboard. It can type scripts into a computer ridiculously quickly, like this week's favorite from Peter TFM. This script that he called the Ugly Rolled Prank creates a VBS script in the user's startup folder and autoplays a really annoying video every single time you want it to. And it can be any YouTube video that you want, so it could be Rickrolling or a very annoying Hak5 episode. We couldn't do this show without your support, so we would like to thank you with something special. Of course, use the coupon code SNUBS with any single order in the Hack Shop for your very own signed HakTip stickers. And if you want me to, I could even sign something special just for you. Thank you so much for supporting the show. We're back with more fun and awesome sauce in Wireshark. So first off, I want to take a look at another graph because I like graphs. They're super handy, and there are a lot of graphs that you can use in Wireshark for all sorts of different things. And this one is actually pretty cool. It's called the flow graph. So you can open this up by going up to statistics and clicking on flow graph. And you'll find this if you scroll down, 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 down. There it is. about halfway down, and you'll have a couple of different options. So you can pick options such as, do you want to look at all the packets or just display packets? So if you change to displayed packets, this will just show you whatever you've displayed under the filter box. Under choose flow type, you can choose a general flow or just a TCP flow. And then down under node address type, you can choose a standard source or destination address as well as network source and destination address. I'm going to leave these as a default and then move on. So I'll click OK. All right, so now we have my graph. Looks kind of weird so far. This is going to be compiled automatically. You're going to see different timestamps, and then you'll see comments about each and every single packet, and in the middle, under the green area is an analysis of each and every packet with the source and the destination. So this can help you visualize each and every packet flow during your packet capture. So for example, if I'm looking for something specific, I can scroll down and down and down until I'm looking for a specific timestamp. So let's say I wanted to find something that has to do with a Dropbox LAN sync. So I'm going to choose this one, and it'll automatically change on my graph below. So you'll notice that it highlights it up at the top. And then I can scroll over and see which specific IP addresses this is going from and going to, how long it took, and further information in the comments. I think that's pretty cool. Now for a little bit of feedback. Howie says, hi, I just recently watched your video Wireshark 101, downloading, displaying, and the BPF syntax. So this is HakTip 117 from our YouTube channel, and he thought it was great, and he wanted to see more about BPFs because he's been researching them for a while, and the information is somewhat scarce, and I have to agree with you. One point he was a little unclear with the video was the capture filters. From what he understands, the capture filters are BPFs. However, the filter section on the main screen of Wireshark uses display filters, which is a separate filter function. The video made it seem like I would enter a BPF on the main screen, which I don't think is the case. Howie, you are correct. There is a difference, and you're right, I didn't clearly specify between the two. But now I fully understand it. I grasp it a lot better after I've done some more research. So first off, BPF filters. So those are a lot different from display filters, which of course are just used to show you a screening of a specific packet from the whole entire list that you see in your capture. BPF filters are created before you even start your capture, so you can choose those in your options before you start the capture. The two are also different in syntax as well, so you can't use a display filter in the BPF syntax and vice versa. So if you try to put in some kind of BPF syntax into the filter box, it's not going to work necessarily. Now I hope that cleared up some of the confusion for you. Of course, let me know what you think. As usual, send me a comment below or email us tips@hak5.org, and be sure to check out our sister show Hak 5 for more great stuff just like this. I'll be there reminding you to trust your technolist. Bye!